Okay, I'm going to discuss absolute value inequalities using two methods. The rules-based method, I'll explain these in a moment. You'll see this example, and I'm going to do it this example as well. And then you're going to see a longer method using the same examples. Okay? So let me explain the rationale for these rules. We're assuming that k is positive. If the absolute value of u is less than k, then it's stuck between 0 and k. And the absolute value is stuck between 0 and k. If I drop the absolute value braces, that opens up a mirror image on the opposite side of 0, between negative k and positive k. Likewise, if the absolute value of u is greater than k, then the absolute value of u is over here. If I drop the absolute value braces, that opens up a mirror image on the negative side, opposite 0. Okay? So I'll explain it again on the next page. If the absolute value of u is stuck between 0 and k, then here's where the absolute value of u originally is. If I drop the absolute value braces, and that opens up a mirror image opposite on the other side of 0, reaching to negative k. And if the absolute value of u is greater than k, then the possible region is over here. And if we drop the absolute value braces, then that opens up a mirror image on the other side. On the negative side. Okay, so let's use this method to solve these two examples. If the absolute value of x minus 17 is less than or equal to 61, then this is one of those in-betweeners. So negative 61 is less than or equal to x minus 17, which is less than or equal to 61. Add your 17 to the middle, to the right, and to the left. And I end up with negative 44 is less than or equal to x, which is less than or equal to 78. In traditional notation, that's the answer in conventional notation. If interval notation is required, then negative 44 is the lower limit, 78 is the upper limit, and because they're both included, they both get square brackets. Okay, that is if interval notation is required. Okay, so next example. This is going to follow this rule right here. So 6x minus 13 is either less than negative 71 or 6x minus 13 is greater than 71. So I will add my 13 to this side, and I have 6x is less than negative 58. I'll finish this one before I do the other one. Divide off the 6, and x is less than, reducing this, and the inequality direction doesn't change because there's division by a positive, negative 29 thirds. This one, I will add my 13 I have 6x is greater than 84. Divide by 6. I'm dividing by a positive, so the inequality direction doesn't change. Okay, now keep in mind these must be disjoint regions. There's no way x can be less than this number at the same time greater than this number. It's not possible. So we're going to have to describe two separate regions. This is everything before negative 29 thirds. So negative infinity to negative 29 thirds. Negative infinity or positive infinity always get a parenthesis. This could get a square bracket or a parenthesis depending on what that sign is. That means that this is strict inequality. That means it doesn't include the number. It gets a parenthesis. Union to link it to this region. Okay, 14 is the bottom. It's not included, so it gets a parenthesis. And everything beyond it. So positive infinity and infinity gets a parenthesis no matter what. And I'm done. Okay? So that takes care of this method, this problem, using this method. Okay? And if this method is adequate for you, you may stop here. If you want to see the other method, which is taught by some, I will show it to you. Okay, critical points and test. You find the critical points. You temporarily convert the inequality into an equation and solve. You plot the points on the number line, closed dot for the or equal to's, open dots for strict inequalities. Those critical points divide the number line into regions, label them with Roman numerals. Test each region in the inequality for true or false. Pick a test point within the region, plug it in the inequality, verify true or false. Shade the true region or regions and describe the true or shaded region, the true and shaded regions. So do. My first order of business is to get the critical points. The critical points are going to be where the absolute value of x minus 17 equals 61. So x minus 17 could equal negative 61, or x minus 17 could equal positive 61, because these two numbers both have an absolute value of 61. So add your 17, x equals negative 44. Add my 17, and x equals 78. Okay. So here's my number line. So this is going to be, I got negative 44, and I got 78. Because that's an or equal to, these will get closed dots. Start over here before the first critical point. This is region 1, region 2, and region 3. Okay, I don't know how clear those separate on camera, so I'm going to write that again. Okay, so I'm going to test region 1. I can pick anything that's less than negative 44. I could do negative 44.01 if I wanted, but I'll just do the first integer, negative 45. I could have done negative 46, negative 47, negative 44.5, just as long as it's less than negative 44. So I want to know if the absolute value of negative 45 minus 17 is less than or equal to 61. Okay, and I need to draw that with a question mark because I don't know that. That's the question. Absolute value of negative 62. And the absolute value of 62 is 62. 62 less than or equal to 61 is false. Region 2. Region 2 has 0, so I'll use 0. I want to know if the absolute value of 0 minus 17 is less than or equal to 61. Question mark. Absolute value of negative 17. (17) less than or equal to 61 is true. Region 3. X equals, it could be anything greater than 78, 78.1, 78.5, 79, 80, anything that's greater than 78. I'll do 79. It's the next integer. I want to know the absolute value of 79 minus 17 is less than or equal to 61. Absolute value of 62 less than or equal to 61. True or false? (62) less than or equal to 61 is false. Okay. So you can use the original number line. I won't, because I like to show my steps in discrete steps. So I want everybody to see all my steps in sequence. Again, you can use the original, but I'm not going to. So I have region 1, region 2, region 3. Region 1 was false, region 2 was true, and region 3 was false. So region 2 was true. And lower limits, so if I was to use conventional notation, x is between negative 44 is less than or equal to x, which is less than or equal to 78. In interval notation, negative 44 is the lower limit, 70 is the upper limit, and they're both included. Square brackets. Okay, moving on. All right, next problem, next example. Do critical points are where the absolute value of 6x minus 13 equal 71. So that's 6x minus 13 equal negative 71, or 6x minus 13 equal 71. So add your 13 and 6x, okay, (6x) equals negative 58. Divide off the 6, and x equals negative 29 thirds. Here, add my 13. 6x equals 84. Divide off the 6. And x equals 14. All right. In the interest of space, I'm going to put this a little bit closer to the numbers. I'm not sure space is going to be a luxury on this problem. The numbers are not included, so they're going to get open dots. Negative 29 thirds and 14. Region 1, Region 2, Region 3. Okay. Test. Region 1. Okay. Negative 29 thirds equals. Okay, I'm going to use my calculator to convert it to a decimal approximation. Okay. That's negative 9 2/3. Okay, or done another way, negative 29, fraction button 3. Okay. Well, I don't think it converts quite. Oh, it does, this button. There we go, negative 9 2/3. So I propose to let x equal negative 10. So I want to know if the absolute value of 6 times negative 10 I'm going to write that a little bit bigger. 6 times the absolute value of negative 10 minus 13 is greater than 71. Okay, that's a question mark. Try to write it more legibly this time. Negative 60 minus 13 is negative 73. (73) greater than 71 is true. Region 2 has 0, so I'll use 0. So I want to know 6 times 0 minus 13 is greater than 71. 0 minus 13 is negative 13. (13) greater than 71 is false. Region 3. I could use anything that's greater than 14, so I'll do 15. I want to know if the absolute value of 6 times 15 minus 13 is greater than 71. So 90 minus 13 is 77. Absolute value of 77 is 77. 77 greater than 71 is true. So, negative 29 thirds and 14. Hollow dots because it's not included, so it's a strict inequality. Region 1, Region 2, Region 3. I determined that Region 1 was true and Region 3 was true. So I'm going to try to push the camera back just a little bit so I can make a little bit more room. So this would be described in traditional notation. This would be negative infinity to negative 29 thirds Oh, that's interval notation. I got ahead of myself. In traditional notation, this would be x is less than negative 29 thirds, or x is greater than 14. In interval notation, this would be negative infinity to negative 29 thirds union 14 to infinity. Okay, traditional notation, interval notation. All right, and that takes care of that.